Let's continue Module 8, confidence intervals for a population mean. Well, before we learn about confidence interval for population proportion, and now we're moving on to population mean. Introduction. Commute time in the amount of time it takes to travel from one place to the other. For example, the time it takes for students at your college to get from their homes to school is going to be a continuous variable. Think about the mean commute time of students at your college. Do you think it's longer than half an hour? Is it less than an hour? Do you think it's similar to the mean commute time for students in your class? Well, in this lesson, we are beginning the process of making inferences about the mean of the population. The mean of the population, remember the symbol was mu. We use the t-distribution to compute margins of error and the confidence intervals for the population mean. With what we learned using the t-distribution, we will make inferences regarding the mean commute time for students at the college. Well, in previous modules, we learned about the margin of error for population proportion. It was E equals to Z sub C. Z sub C was our critical value times square root of p hat times 1 minus p hat divided by n. And remember that p hat was the sample proportion. The confidence interval that we had was p hat, or the point estimate, minus margin of error, comma, p hat, or the point estimate, plus margin of error. This is our confidence interval when we have proportion. Remember, we moved on to the mean, so we have to use different point of estimate, and definitely we get a different margin of error. We use sample means, X bar, to estimate the population mean. Remember that T, or the standardized test statistic, is defined as X bar minus the mean divided by S. S is the sample standard deviation times square root of n. So S is the sample standard deviation. The test statistic varies according to t-distribution with the degrees of freedom equals to n minus 1. Degrees of freedom is n minus 1. To compute the margin of error in a sample mean, we multiply a t critical value, not ZC. Remember that. When we were using the proportion, we had critical value ZC, depending on if we have 90% confidence interval, 95% confidence interval, 99% confidence interval, we had different critical values. Now that we moved on, using t-distribution, instead of Z, we're going to use T critical value. The margin of error in a sample mean, again, sample mean or X bar, is given by E equals to TC. TC is called the critical value. Critical value times S divided by square root of N. S is sample standard deviation and N is the sample size. Well, in this case, our point estimate is going to be the same as sample mean or X bar. And the confidence interval is equal to X bar minus margin of error, comma, X bar plus margin of error. Or another way to write down the confidence interval is saying that the population mean is in between X bar plus minus margin of error. So the question is, how do we find this critical value? We already know how to find the sample standard deviation and must be given to us, but what about the critical value here? How do we find T sub C? There are several important things to remember about the T distribution. The population of the T distribution contained between the critical value T sub C and its opposite is equal to the confidence level. The T distribution varies with degrees of freedom or N minus 1. T critical values depend on both the confidence level and the degrees of freedom. Well, we have a nice table that helps us to find the critical value TC. After calculating degrees of freedom, which is N minus 1, this is our very first column that is related to degrees of freedom. So the first column, or the degrees of freedom. And the first row, which is the confidence level. The intersection between the first row and the first column is our critical value. Let us go over one example together. Suppose that researchers measured the resting pulse rates of adult males who were involved in a study of the effectiveness of a bicycle exercise regime. The table below shows the participants' pulse rates. You should assume that these values are sampled from a normal distribution. Remember that if we don't have a normal distribution, we cannot use Z, we cannot use T. So using T, using Z, they both depend on having a normal population. Question says, construct a 90% confidence interval for the mean keyword, for the mean resting pulse rate for all adult males. This is the collection of the data that we have. How many data do we have? What is N? What is S? This is a sample. What is the standard deviation? And since we want to find the confidence interval, we need to find T sub C and the margin of error, which is TC times S divided by square root of N. So we have our collection of data here. How many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 41. So N is equal to 41. What is our S? How do we calculate S? So to find S, we can use our calculator. Let us turn on the calculator. There we go. Let us enter all the data in L1. So we're going to go to Stat. We're going to go to Edit. And I already have some data, so I'm going to erase them all. The numbers that I have, 65, 82. So 65, 82, 87, 64, 77, 89, 77, 73, 78, 88, 79, 83, 85, 87, 82, 91, 87, 85, 87, 73, 88, 78, 74, 78, 88. Well, here I have 82, 77, 59, 97, 84, 87, 85, 87, 83, 79, 73, 83, 85, 87, 91, and finally 99. Now we go to Stat, we go to Calc. We're looking for one variable Stat, so enter. All numbers are in L1, so I'm going to leave it as L1 and calculate. My X bar, the mean is 82, so let us write down X bar here. 82, and the standard deviation for the sample is 8.13. Okay, now what is the critical value? To find the critical value, we can use our table. So degrees of freedom is n-1. We already know that n is 41. So n is 41. Degrees of freedom is 40. We need to find 40 on the first row. Well, it is located here. And the question says, the confidence level is 90%. 90% with degrees of freedom equals to 40. The intersection between them is going to be 1.68. So 1.68. Well, now we can easily find the margin of error. The margin of error is equal to TC, which we found as 1.68, times S divided by, so S is 8.13, divided by square root of 41. By using our calculator, E is 2.133. Now that we have E, we can easily find the confidence interval, which is X bar minus E, X bar plus E. So the confidence interval is equal to X bar 82 minus 2.133, which is approximately 79.867, and X bar, which is 82, plus margin of error 2.133, or 84.133. So we are 90% confident that the population mean is in between 79.867 and 84.133.